Hi friends, in this video we are going to discuss about previous gate questions in our DC machines. Actually the question is very big to lick, but generally the answer is very small. See here carefully. A separately excited DC generator has separately excited DC generator. For example, the DC generator. This is my separately excited DC generator. For example, here excitation, separate excitation. This is my armature resistance. They given 0.1. Armature resistance 0.1 ohms. This is connected to a supply voltage V. S. Separately excited DC generator has armature resistance 0.1 ohm. Armature inductance negligible. Armature inductance negligible. At rated field current and speed, its open circuited voltage 200 volts. So open circuited voltage 200 volts. When this generator is operated at of the rated speed of the rated field current. Generally under no load condition 200 volts. This is generated EMF actually. Under no load condition, generally EZ is equals to what is the formula? V plus IARA. At open circuit condition IA 0 and EZ is equals to 200 volts at open circuit condition. At open circuit condition, EZ is equals to 200 volts. Right. Now what they said? Off rated speed, off rated field current. Generally, EZ2 by EZ1 is equals to N2 by N1 into phi2 by phi1 because EZ directly proportional to N into phi. EZ directly proportional to N into phi. Now I want EZ2. Tell me EZ2 is equals to 200 into N2 by N1. N2 is equals to N1 by 2. N1 is equals to N1 because they said that rated of the rated speed of N1. Next, flux also off because of the rated field current. Nothing but phi2 is equals to phi1 by 2 and phi1 same. Phi1 cancel, N1 cancel. 200 by 4 nothing but 50 volts. This is my EZ2. Under off the rated condition, my this EZ value is 50 volts at off the rated condition. Off the rated condition. Then what happened? See here. An uncharged 1000 microfarad capacitor suddenly connected across the armature. What happened? Suddenly across the armature, a uncharged capacitor connected. Uncharged capacitor connected with 1000 microfarads capacitance. This is my capacitor now connected across this one. Okay, connected across the armature. Assume that the speed remains unchanged. Even though this capacitor connected, there is no change in speed. Next, at what time after the capacitor is connected with the voltage across it, the voltage across capacitor reaches to 25 volts. At what time the capacitor reaches to 25 volts? How much time it will take to reach its 25 volts is the question. How much time? These are the options they given. How much time it will take to charge up to 25 volts? To charge up to 25 volts. So here EZ is equals to 50 volts. This is the source voltage and this is the capacitor voltage and this is the resistance. Okay, now I am removing this one. There is no use of this one now. Just we have to know that 50 volts is the EZ. 50 volts is the EZ. That is enough. So now I am removing this. I'm removing this. Let's see here. Now this circuit is like this. This is 50 volts and this is my resistance 0.1 ohms, and here one capacitor is connected. One capacitor is connected 1000 microfarad and reached up to 25 volts. Yeah, this is my circuit finally. Now we are in network theory, right? Tell me what is the loop equation for this. The loop equation, we see the voltage across the capacitor is equals to the source voltage into 1 minus the source voltage into 1 minus e to the power of minus t by tau, e to the power of minus t by tau, e to the power of minus t by tau. This is generally our answer. Yes or no? In RC circuit. Tell me what is VC? 25 volts. What is source voltage? 50 volts into 1 minus e to the power of minus t by tau. What is tau for this circuit? Tau is equals to RC. R 0.1 into C. C nothing but 1000 microfarad. Nothing but 1000 into 10 to the power of minus 6. Tell me what is the value. 0, 0 gets cancelled. Nothing but tau is equals to 10 to the power of minus 4. Tau is equals to 10 to the power of minus 4. RC is equals to 10 to the power of minus 4. See here carefully. Tau is equals to RC. R is equals to 0.1, nothing but 1 by 10. C is equals to 1000 micro. Micro nothing but 10 to the power of minus 6. 0, 0 gets cancelled. 2 zeros minus 6 minus 4. Yeah. Let's see here. Let's see when it comes to here. 1 by 2 is equals to 1 minus e to the power of t by 10 to the power of minus 4. Yes or no? When this, I am writing here, e to the power of minus t by 10 to the power of minus 4 is equals to, it comes to plus, minus, nothing but 1 minus 1 by 2, 1 by 2. Yes or no? Right, minus t by tau is a 1 by 2. Now tell me, what is the value? Minus t by 10 to the power of minus 4 is equals to ln of 1 by 2. Ln of 1 by 2. Yes or no? Ln of 1 by 2. E to the power of t by tau, ln of 1 by 2. Now tell me, what is t? T is equals to 10 to the power of minus 4 into ln of 2. What is the value of ln of 2? Generally, the ln of 2 value 0.693. Yes or no? Natural logarithm of 1 by 2 is equals to this value 0.693. 0.693. Right? Now tell me what is t? T is equals to 0.693 can be written as 69.3 into 10 to the power of minus 6 seconds. Minus 6 seconds. Yes or no? See here once clearly. Here e to the power of minus t by tau. This value 1 by 2 minus t. Of course it's minus t. T, for example, t. We are taking t. 0.693 into 10 to the power of minus 4. Its value 69.3 into 10 to the power of minus 6 seconds. Yeah, see which of the following is correct answer? This is the correct answer. 69.3 microseconds. Very simple question. Right? Okay, sir, next question. This is our question, right? Yeah, see, DC motor has the following specifications. What are the specifications? This is 10 HP. 37.5 230 volts. 10 HP, 37.5 amperes and 230 volts. The flux per pole they given 0.01 Webers. Number of poles 4 and number of conductors 666. And parallel paths also they given 2. And armature resistance also they given 0.267. Right? Now, armature reaction negligible, they said that. And rotation loss are 600 watts. Motor operates from 230 volts DC supply. Speed also they given 1000 rpm. 1000 rpm. The output torque produced in Newton meters. The output torque produced in Newton meters. Now we have to find out the output torque. So generally torque T is equals to P into omega. P into omega. Right? So torque T is equals to P nothing but EB into IA into 2 pi n by 60. We have to find out EB. EB is equals to phi z n by 60 into P by A. What is phi they given? 0.01 Webers multiplied with number of conductors 666 multiplied with speed 1000 divided by 60 into P by A. Number of poles are 4 and number of parallel paths are 2. So 4 by 2. If you calculate this value, you can get the EB value 222 volts. 222 volts you can get. Now again, we want this armature current, right? How we can find out armature current? Generally we know this is a motor. This is a motor. So EB is equals to V minus IA into RA. V minus IA into RA. EB they given 222. Actually we calculated. And V they given 230 minus IA into RA they given 0.267 ohms. If you calculate this IA, you can get IA is equals to 29.9625 amperes. This is our EB back EMF and this is our armature current. Then substitute all the values here. Substitute all the values here on the torque equation. On the torque equation, then tell me what is our answer. EB nothing but 222. IA nothing but 29.9625. 2 pi n by 60. 2 pi n by 60. If you calculate this value, you can get 57.8 Newton meters. 57.8 Newton meters. The torque T developed by the motor is equals to 57.8 Newton meters. Yeah, very easy question. Actually, we find that EB. After from that EB, I calculated IA. After that, I substituted all the values. Then we can get the answer. What is that? The answer is 57.8 Newton meters. It's a very simple question, right? A big question, right? Let's try to solve this. Okay. See, a separately excited DC motor runs at 1000 rpm on no load. What is that? They given no load. No load. The speed is 1000 rpm. The speed is 1000 rpm. Next, when its armature terminal is connected to 200 volts, nothing but the supply voltage connected to 200 volts. 200 volts DC source, and the rated voltage is applied to the field winding. Field winding also connected to rated voltage, and armature resistance they given 1 ohm. No load armature current negligible. No load armature current negligible. At no load armature current 0. At no load my armature current is 0. Then tell me what is the formula actually. EB1 is equals to V minus IA1 into RA. They given that IA1 0, so this value 0. So what is EB1? EB1 is exactly equals to 200 volts. Right, sir. This is at no load. This is at no load. Next, armature current negligible. With motor developing its full load torque, armature voltage is set that the rated speed is 500 rpm. Here the torque is a full load torque. And the speed is 500 rpm. When the load torque is reduced to 50%. Now the torque is reduced to 50%. The full load value under the same armature voltage condition, the speed rises to 520 rpm. This is a torque is equal to full load torque. This is a torque is equals to half of the full load torque. The speed is 500. The speed is 520 rpm. Neglecting the rotational losses, the full load armature current I want that full load armature current. Here, generally, here EB2 by EB1 is equals to N2 by N1. EB2 is equals to EB1 into N2 by N1. N2 by N1 is equals to 100 volts EB2. EB2 is equals to V minus IA RA. RA they given 1 ohm. We don't know IA. This is IA at full load. We don't know voltage also. So EB2 is equals to 100. That is equals to V minus IA at full load. Nothing but V is equals to 100 plus IA at full load. V is equals to 100 plus IA at full load. This is at full load one equation. Let's comes to off load. N3 okay. EB3 is equals to EB3 by EB1 is equals to N3 by N1. Then EB3 is equals to EB1 into N3 by N1. 52 into 2, 104 volts. That is EB3. But EB3 is equals to V minus IA into RA. Off load, right? Off load nothing but generally full load by 2. Off load armature current is equals to full load current by 2 when load is directly proportional to current. Now tell me what is the value? 104 is equals to V minus IA at full load by 2. Then V is equals to 104 plus IA at full load by 2. V is equals to 104 plus IA full load by 2. This is also V and this is also V. These both are same. We have to equate these both. Then we can get IA. Yes or no? What they asked? The full load armature current they asked. So equate these two equations. Equate them. See here. Equate them. I am equating here. 100 plus IA at full load is equals to 104 plus IA at full load by 2. Right? Now tell me here IA at full load minus IA at full load by 2 is equals to 104 minus 100. Nothing but IA at full load by 2 is equals to 4. Nothing but armature current at full load is equals to 8 amperes. Armature current at full load is equals to 8 amperes. What I done here? A very simple question. Actually, to see it is a big question. To see it is a big question. But we have a clear data here. To do that, to solve the answer, we have a clear data here. See here, actually at no load, they given speed. And they given that armature current is negligible. Then back EMF. Then at full load condition, back EMF and supply voltage. At half load condition, back EMF and supply voltage. Both voltages are same. When load changes, there is no changes in supply voltage, right? So both voltages are same. When we solve this equation, we can get 8 amperes is the full load armature current, right? Okay, next question. A 4-pole separately excited wave-wound DC machine with negligible armature resistance is rated 230 volts 5 kilowatts. 230 volts 5 kilowatts at speed of 1200 rpm. The same armature coils reconnected for lap winding. Reconnected for lap winding. What is rated voltage and power respectively at same speed? Rated power and voltage respectively at same speed, nothing but 1200 rpm of the reconnected machine. If the field circuit is left unchanged, if the field circuit is left unchanged, then tell me the answer. What are the power and voltages? Generally, we have a small formula here, a small relation. Generally, the EMF in lap winding to the EMF in wave winding is equals to the number of parallel paths in wave winding to the number of parallel paths in lap winding. This is the relation. Very, very, very important relation. And also, the current in lap winding to the current in wave winding is equals to the number of parallel paths in wave winding to the number of parallel paths in lap winding to the number of parallel paths in wave winding. Generally, the parallel paths are directly proportional to current, right? In generally, parallel paths, if parallel paths are more, current is more. Yeah, we have these two equations. Let's solve it. We have to know the EL, the EMF in the lap winding. The EMF in the wave winding, they given 230. And they given AW. Can you tell me number of parallel paths in wave winding? 2. Number of parallel paths in lap winding? This is a 4-pole machine. So tell me EL is equals to 230 into 1 by 2, nothing but 115 volts. 115 volts is very easy answer. And the voltage is completed 115 volts. What about power? To calculate power, we should know the current. Actually, there is no current value. We don't know the current value. But let's check it. What is the current with respect to IW? Let's check it. IL is equals to IW into AL. Number of parallel paths in lap winding 4 and in wave winding 2. Nothing but IL is equals to IW into 2. Nothing but in lap winding current is double the wave winding. In lap winding voltage is half of the wave winding. Right? Yeah, this is 115 volts. And here we have to find out the current. But generally, we know that they given power P is equals to 15 kilowatts in lap winding. In wave winding. In wave winding, P is equals to 15 kilowatts. V is equals to 230 volts. Right? Then, can you tell me I is equals to? I is equals to 15,000 by 230 volts. This is IW. This is IW. Then tell me what is IL? IL is equals to IW. IW value 15,000 by 230 into 2. Yeah, yes or no? IW, I calculated my IW value. IW, P given, V given, then IW. IW is equals to P by V. Then tell me is ones and 115. So my IL is equals to 15,000 by 115 amperes. I got IL and of course this is not useful now. EL. Now can you tell me what is the power? Power is equals to V into I. V into I. 15,000 by 115. 115 gets cancelled. So 15 kilowatts is our answer. 15 kilowatts is our answer. Okay? A very easy question. Actually, we have two relations here. EL by EW is equals to AW by AL. IL by AW is equals to AL by AW. Nothing but the current is directly proportional to parallel path, but EMF is inversely proportional to parallel path. From that I calculated EL, and from that I calculated IL. Before that I calculated IW. Then after the power is equals to E into I. The power is equals to E into I. For example, if you multiply these two, we can get 15,000 kilowatts. It's a very simple question actually. Right? Okay, sir, next one. See here, DC shunt generator it is. Draw the DC shunt generator. This is my DC shunt generator. They given armature resistance 0.01, field resistance 44 ohms, voltage, terminal voltage 220 volts. This is the given. Generally, this is what ISH, this is what IA, and this is what IL. Yes, sir. Now tell me what they given. Stray losses they given 375 watts. Then find efficiency of the motor. First, can you tell me what is ISH? What is ISH? ISH is equals to V by RSH. 22 tens are 22 twos are. So tell me ISH is equals to 5 amperes. ISH 5 amperes and line current they given 45 amperes and armature current 50 amperes. Yes or no? Is it 50 or not? When this is 50, 5 plus 45. 5 plus 45. Yeah, I got armature current. Now, the stray losses they given, but copper losses we have to find out. Tell me what are copper losses? IA square RA losses and ISH square RSH losses. What is IA square RA? 50 square into 0.01. ISH square 5 square into 44. If you calculate all these, if you calculate these two losses, its value 1125 watts. 1125 plus 375, finally 1500 watts total losses. Total losses 1500 watts. Yeah, 1500 watts is the total losses. What is the output? The output is equals to V into IL. 220 into 45 is the output. This is the output. These are the losses. Right? Tell me, what is efficiency of my generator? Generator efficiency is equals to output by output plus losses. Yeah? Output by output plus losses. Output 220 into 45 divided by 220 into 45 plus 1500. If you solve this, you can get 0.86842. 0.86842. Nothing but the generator efficiency is 86.84 percentage. This is my generator efficiency. Very easy question. See here the question. A 4-pole. How many poles are there? 4 poles. Lap connected. Lap connected, nothing but number of parallel paths also 4. Separately excited DC motor drawing steady state current of 40 amperes. Nothing but the total armature current of 40 amperes. While running at 600 RPM, a good approximation for wave shape of the current in armature conductor. Wave shape of the current in armature conductor. The motor is given by this motor given by. Let's see first. We have to know the current in each parallel path. Yes or no? The current in each parallel path. The current, armature current in each parallel path. Tell me total armature current by number of parallel paths, nothing but 10 amperes. The current in each parallel path equals to total current by parallel paths is a 10 amperes. Yeah, I got amperes. Next, we have to know the time period, right? For that, we have to know the frequency. N is equals to 120 F by P because the EMF induced in the armature is AC. Don't DC, right? It is not DC. The EMF induced in the armature is AC. So N is equal to 120 F by P, where N is the 600, 120 F by, where P is number of poles 4. 120 ones, 125s. So F is equals to 20 hedges. F is equals to 20 hedges is correct answer, but I want time period. Time period T is equals to 1 by F, nothing but 1 by 20. Tell me, 1 by 20. 1 by 20, nothing but 0.05. So time period T is equals to 0.05 seconds, or simply 50 milliseconds. We can written as 50 milliseconds is the time period. The total time period 50 milliseconds. Now give the wave shape. The wave shape. Generally in DC machine, the EMF induced is trapezoidal. In the armature, the EMF induced is trapezoidal, right? So the value should be like this. This is the wave shape of the armature current. What is its maximum value? Is value 10 amperes because we calculated already 10 amperes. What is its time period? The time period is 50 milliseconds. 50 milliseconds, nothing but here 25 milliseconds. 25 milliseconds. This is the wave shape of the armature current in the conductors. Yeah, very easy. Here 10 amperes, 25 milliseconds and 50 milliseconds. This is about the question explanation. See, just we have a IA total per parallel path current, then after frequency, then after time period, then after wave shape.